Morning.
Good morning, everyone. Happy Saturday.
Hey Luis, good morning.
Hey, good morning, Luis.
Good morning, everyone. Hoping having their coffee already and
I'm having my tea.
good. We'll just wait for all others to see to join us. So one more minute and then we'll start.
Are you more towards Toronto side or Vancouver side?
So Toronto, North Toronto's on East Coast.
Oh, I see, I see. Okay.
So just a little bit 3 hours ahead.
Got it. Okay, okay.
Okay, I think we'll just start now. I think more people will be trickling in as we get through. But yeah, this is week six. Week six, we're going to recap a little bit what we've done over the few weeks. Understand a little bit more how all this now ties together into one system. We'll be walking through how to do something like this in production and talk about the different parts and moving parts of actually putting this into something that's real in certain companies, or you want to do stuff yourself. So a lot of people asked me during the office hours if we could just give what key definitions of things that we talked about of what is a RAG and what's not a RAG, what are agents, what are not agents, what's an MCP, what is not an MCP. So we can give a clear definitions of what these mean and understand again, just make sure things are clear. So what is RAG? We know from we did in 101. So it's a technique that uses data, external data, and retrieves it and gives it to an LLM before responding, right? So we know that a RAG is something where you can constantly update. You can update the documents, you can update the embeddings, and you use that retrieval method and process to feed to your LLM because it knows something, it has something it doesn't know. What is not RAG? RAG is not fine-tuning a model. You're not modifying the existing LLM, and it's not static, so it can't access current information without retraining. So just remember the difference between RAG and fine-tuning. Fine-tuning, you're actually editing, you're going in there, changing the weights of what an LLM thinks by different ways. Remember, we talked about LoRa, QLoRa. That's what we talked about sort of week two. That's where you fine tune a model to make it more condensed and precise for certain documents. And then you have a RAG where you're not editing the LLM at all. You're using typical NLP techniques, which are using embeddings to verify one document against another. So again, just make sure that's clear definition. So anytime that talks about RAG versus fine tuning, you know for sure. So what's an AI agent and what's not an AI agent? Sorry, there's a question in the chat on that. So an LLM, it can talk to your RAG if you set it up properly, right? So an LLM is frozen. Let's say it was trained only on March data, right? So then you set up a framework using either LangChain or you use any other, you can use your own Python where it says, if there's anything that's very similar to the user's question, retrieve it from this box and then give it to the LLM before responding. You're appending information to an LLM. The LLM reads the appended information and the user's question and able to give a response out, right? So we're extracting that information and giving to an LLM. So, oh, here's some extra information I didn't have before, and then give that part out. So an LLM is then in that framework given that LLM. It becomes an AI agent when you ask an agent to then go retrieve certain things, right? So, an AI agent, the difference between our like a normal LLM and AI agent is an AI agent is given a framework and given tools to then decide which tools to use in order to get that information out. In a typical RAG, it's not given options. It's saying every single time you see a question, it has to process this flow, and that's the endpoint. Meanwhile, an AI agent is given multiple tools and a goal, and saying you can think about this, you can reason, you can go back, you can iterate to achieve the goal that you need to have. So an AI agent is a system that uses LM to perceive, to make decisions, takes actions, and comes to the final end. So an example of this is a system that books flights by searching, comparing, and purchasing, right? It's like, okay, find me the cheapest flight to go to Dubai. So this AI agent will then use your API, pull all the flight information in, then will analyze it for you. And then because you said purchase, if you connect it to a certain credit card or anything like that, can go in, purchase the most cheapest one for you, and then send you a confirmation. Hello, I found the cheapest date to be this date. I have analyzed it, purchased this for you, and here's your final task. So you can see the difference between just doing a simple LLM call, which is um, what's the cheapest flight out there? And LM Call could go to Tably, pull information out, bring it back. So the cheapest flight right now I see is this Thursday at 10 p.m. Right? That's a chatbot that has a little bit some tools and go in, ask questions, come in. But an AI agent is given tools to actually act and use those tools to execute. So that's correct. So agentic AI is the same as AI agent. They're changed interchangeably in terms of terms. So a chatbot, not a single LLM, is not deterministic, it's passive. Meanwhile, agents actually pursue goals. So example, a simple QA bot that only answers from a knowledge bank is not an AI agent because it's simply retrieving information, getting back to it, and it doesn't have an overarching goal and decisions to know which tools to execute. If you're giving it exactly what it needs to do, it needs to go from point A to point B, point C, and comes out with point D. You're building a framework in which an LLM is being used. But if you're building an agentic AI that has tools and say use any of these tools at your disposal to answer questions, now you're giving liberty to these LLMs to then decide, act, and get a final plan from there. So again, MCP, what's an MCP? We talked about that before. So it's an open standard protocol that standardizes how we connect to external devices. Think of like a USB-C, like I said before. You're connecting to these different areas and you're using MCP to sort of grab context, contain history, and sort of have it. What it's not, MCPs are not AI models. It's not a RAG. It's not proprietary. It's not required for agents, but it makes your integration easier. For example, a custom API you built to retrieve information for your chatbot and giving it back is not an MCP server. As we saw before from week 4, in order to have an MCP server, you need to register it, you need to have it in open API configurations, you can do authentications, you can set up context and history. It's more than just building a custom API that's pulling information. It's sort of building a framework of authentication and giving it tools and definitions. Then LLM can say, oh, I can just pull all these tools rather than just giving it in your text one API that only does one API call. So let me ask a good question. In the flight purchasing agent, what makes it agentic rather than automation? So I'm gonna think of it again as your automation flow. You're in an automation flow, you're saying first one, search for a flight. Search two, purchase the flight. Search three, give confirmation. That's automation. But what happens if, how do you make this agentic? Is you tell the AI agent, um, hey, you have access to these tools to analyze. So it looks for the cheapest flight. But guess what? The LLM takes an extra step because you told it to then compare it to three other sites. So not only it's going to pull from one site, it goes back to two, go back to three. But guess what? It received an API error because you wrote something wrong on your automation tool. Then usually on an automation flow, it would just die. But an AI agent can then correct itself. Oh, looks like they required this field. Let me try again using this format, and then it will retry and retry and retry, trying to get that decision based off its knowledge. And sometimes it will succeed if you give it enough tools to go retry, get more information out. And it's like, I wonder if I look at this. So instead of just giving it one task of just pulling at one site, pulling information, or looking at multiple sites, it actually steps back, analyzes. If anything stops and fails, it's able to retry, look at it based off that overall goal that you can put in an AI agent. And now that's gone over three different areas and it's able to make a decision and that's saying it feels like it's met its goal. And then it goes like, okay, now I will then compare these using analysis, right? So then it can then format it the way you want. If you want to make it to a SQL, make it to a table, you can make it into charts, you can do different things, right? So again, the difference between that automation line and an AI agent is you're not telling it can only do these workflows and that's it. These AI agents now have a little bit more autonomy to actually decide how to adjust filters or what other searches they can do that's a deeper search versus that. So again, that decision making is what is really the difference of making something automated versus an AI agent that has an overall goal and decision to do that. So hopefully that can clarify. Yes. Okay, so I think hopefully that will give a good refresh and clear up those definitions as we go through this intermediate side, and let's get into some today's class. So we learned that yes, we can create these RAGs, we can create these AI agents, and we built them, right? We worked in class together, we built these, but in 102, we know there's extra cost that comes with them. We know that there's how do you take that to production now and actually make something that is hardened, make something that actually is actually usable. And we're going to take little bits and pieces what we learned over the couple of weeks now to sort of put them in and understand that when you look at something for a business and you're looking for something towards building your own or for your own enterprise, you need to think about all the moving pieces that happen in an AI infrastructure and AI agents. And there's one thing that I think I shared in the first week of class. No, the first class, no, in the first week class, in 101 was an article, and this article was called "Dear IT, Stop Trying to Build Your Own RAG," and talks about how most IT individuals from top leadership would say, "Well, this looks pretty simple. I can just deploy my own RAG in my own department. We can just do it there. We'll just pull in software engineers. We just have to just create the same flow, and that's it." But this requires a whole different operation than you think. And again, if you ever heard the term of ML ops, machine learning operations, there is something for AI called AI ops, which is AI operations. What are best practices and really how do you develop a good framework of developing and deploying AI agents in production? that you need to keep in mind. So we talked about, for simplification, we'll be looking at RAGs because it seems to be an easier concept of how things sort of being pulled in. But the same things, RAGs can then easily be like the vector store can easily be interchanged with an MCP, or that can be changed to many different things. So building your AI agent, you think, okay, I did it, I'm done. So I just put a big note here. It's not enough. You need a complete production infrastructure for this to work. So one example here is you need to have a database that stores information from your AI agent. So that's number one when you think about when you build something like this. Where is your data being stored? So from 101, we talked about different vector store databases, things like that. But when you think about building this, where is your agent going to live in? Is it going to live on local? Is it going to live on a server? Is it going to live on AWS? Is it going to live on Databricks? Is it going to live in Azure? Where is your system going to live? And where are you going to have it be run on the cloud, right? So your first step is understanding where is my database. So if you already have a pre-existing database from your enterprise, you're like, okay, that's what I know I can use from there. But if you're building your own, you want to build your own productionalized systems and you want to make this a business, you need to think about where you can get the best bang for your buck in terms of having data storage. And the reason why I'm going to tell you this is because a lot of vendors say they do vector storage. A lot of vendors say, hey, we do vector store indexing, we can store your chunks, we can store your documents. But what they don't tell you is that doesn't matter if you activate it, there is a monthly fixed fee. So some vendors will charge you a fee for how many documents come in. So let's say you're just starting off and you only have 20 documents. You shouldn't be paying $500 USD a month to host 12 documents on your vector store index. That's really a lot of money for just for a POC or MVP that you're sort of building out. You would start paying that much once you start having millions and 1.5 millions of tokens, like you're having lots of enterprise data coming in, then it makes sense for you to have something very big. But again, we'll go to think about different options. What are some cloud providers right now that are doing vector store indexes for your RAG? And what's the cheapest option of even hosting something, keeping it active? And if there is a cost or can it be scaled down? Let's say you're not using your vector store every single day. Let's say you're using it once a week and twice a week. Is there scaled down options where you don't have to pay for it when you don't use it, right? So these are the things I want you guys to think about when you're thinking about building a productionalized AI system, is that you need somewhere to store your information and also store where the LLM is going to be living. You need to be having a place you can store where you can store your inference tables. So if the first time you heard the word inference, inference means the communication that happens between the user and the LLM. So all that communication between a user and LLM is called inference. And inference is where you count the tokens. So if you want to keep a history of what's going on with your LLM, you need a database for that. And if you want to do caching and you want to cache your LLM, you need a database storage for that. So again, where you host your LLM is one of the most important parts. Someone had a question?
What is the caching LLM? What do you mean by that actually?
Yes, so in order for most people who want to save tokens, they want to say, I don't want like I'm doing a RAG chatbot. Most people ask the same questions. You can do something called caching.
Mhm.
Azure has this something called Redis Cache as well, where you
Okay.
can store previous questions and answers that the model gave into this Redis cache, and you can have your model pull from that Redis cache first before answering the user's question using your whole pipeline. So you say, has this question been answered before? If
Ah,
yes, go to your risk cache, extract the answer out, and feed them that response. That costs you 0.00001 cents versus going through your whole pipeline, extracting the answer out, and then costing you 0.05 cents, right? You can
essentially
How would
caching.
is what would be
Essen
the difference between the just the regular Redis as well as this. So do they kind of like optimize for retrieving the core tokens and make it more friendly with the agentic AI, or what is it?
For sure. Just sort of, you were finishing. Sort of, I'll answer your question. Finishing your question, Satya. You had one.
Yeah, exactly. Sorry. So you're referring to as caching LLM results and not really caching LLM.
Yes, caching the results. We're not caching
Yeah,
out
I really got confused when I said caching LLM, like how LLM,
results. Results.
right, right, results of the LLM. But considering that, like say, the case that you took was an the chatbot, right? What
Yes.
if it is an, like you shouldn't be caching the LLM results from a chatbot if it's user specific, right? Because then it's a security concern, right?
So it depends on your use case, right?
Sure. Okay.
So if it's a simple FAQ chatbot that you have,
Correct.
there's
Okay.
ways to automate that. You can, but if it's something that's private and current, then you definitely don't want to use caching for that.
Right. Right. Yeah.
So yeah, so Nagesh asked a good question. So what's the difference between this cache and this Redis cache that I'm talking about? So Redis cache is what just Azure has it. You can use any other caching mechanism you can think of. You don't have to stick with Redis cache. Redis cache is sort of like a big known one that Azure has that you can use. You can do this locally too. You can create your own cache files if you're building something local. Save them on JSON, save them as text, whatever it is, and store them on your local drive. Just these, I just know Azure Redis cache has sort of been optimized to be super fast and speed. That's why I sort of suggest to use something like that. But it's not your only option. You can
So
use,
is the keys to the cache is the tokens?
yeah. So you'll see in when you look at these Redis cache, is actually the user question response in there. So to get the keys to a Redis cache when you're trying to communicate with it, just like a normal API, you need tokens, you need authentication as well. So this is what's really important about this when you think about in production. When you implement something like this also needs authentication. You need to have tokens from that caching center from Redis Cache to pull information out and pull information in.
Oh, so purely we are talking about the authentication tokens here, not any other tokens which we like the tokenization or something like that of the data. Is it? Because when you're saying the result gets cached, I just want to be clear about it.
Yeah, so when I say result means cache, just like Satya was saying, is just the chat history. So let's say you can, instead of, a user can go back and forth between histories. What you can set up your cache is you don't have to have it go back and forth on your cache. You can separate each question into separate sections, depending on the user. Example, if you're doing a RAG, this would make sense. Because as user asks, how do I activate this product? And it's going to give a response. And if you want it to be consistent and not pull different responses every time, when you answer when the chatbot answers that response, that conversation interaction can then be saved as an interaction in your cache history. So then when a user asks that, another user logs in and asks the same FAQ question, instead of going through your whole pipeline, it will look through your cache first, look for anything that's very similar and very you could put your own guardrails, like has to be 95%. It could be 96%. Similar to the user's question, pulls that and gives the answer out that's already been saved in your Redis cache, and then uses that to respond to the user instead of going in and using in your whole pipeline. And the whole purpose of this is to reduce your time to response from, let's say it takes you 4 seconds to answer a question with your RAG. Now you drop to 0.015 milliseconds, and you're saving money because you're not using LLM to do the same inference again.
Got it. So the agentic AI will use the steps to know whether to retrieve from the cache or from the RAG.
Yeah, this could be a rule that you could set up. You don't have to it doesn't have to be agentic AI. It could be in the sense that when you receive a response from a user, check your cache first. And if anything in the cache matches, send it off. If not, again, you're making that if statements. If not, go through pipeline, right? So an AI agent doesn't have to think about going through cache. You're already building that step in to do that semantic. Because if you have an LLM to think about pulling cache, that would then you're removing the purpose of having cache because you want to reduce the tokens of it, right? So before even it goes to the LLM, you can build this out to look for it.
It could be a semantic search, right, Luis? Not necessarily the like I would say, if you use RAG, then you need to convert what is stored in the cache as vector embeddings, correct? Else you can always do an semantic search, but of course, like you need to give that back to the LLM to see that semantic closeness to the question that is asked versus the results that is being sent back, correct?
So there's different, yes, exactly. So there's different ways to pull information from Redis cache. One, you can do it semantically.
Right.
You can do it through keywords. You can do different types of retrievals with your Redis cache to determine which one actually is best matching to the user's
Right.
question.
Yeah.
So let me ask you a question. To use, not use cache is determined by LLM. Could there be a layer? Yeah, so you don't give this to an LLM, Swami. You give this before giving it to your LLM. You set this up as a step before you process and you send the the query to your LLM to start ingesting it. So it's like a catch-all to do this. Where this information gets stored, example in here, is called your long memory. This is called your cache, your long memory, because again, this is historical information from all your previous transactions that you can have it in, right? So before you give it to an LLM model, it goes in and stores this into that cache area. That's really good. So this is one of the ways how you to optimize RAG chatbots. So great questions on that.
Actually, it's really interesting, Louis, that you brought in the cache layer or a semantic search and all of that stuff. People are trying to now do everything either with the vector databases. Sure, like searches also could be the part of the vector databases, but people only talk about the RAGs, LLMs, and MCPs. Like now, not much about this. Oh, we can use a vector. I mean, the search indexes or like semantic searches as a complement to the the LLM or this agentic loop, right? In the agentic loop, essentially.
Yeah, to me, that's the difference between someone's actually gone in and actually worked with these before versus just
Uh-huh.
talking about theory.
Yeah, this is great.
So
So can we consider cache a separate thing as RAG, or would it be appropriate to call that as the part of the RAG as well?
it would be part of your RAG infrastructure, right? It's just a process. So, because your step one, take the user's query. Step two, check cache. If there's not cache, send it to step three, which will be your pipeline now. Now it goes to your LLM will now embed that response, go look for the retrieval, pull the response out, then give it to the user, right? So it just becomes one of your framework. It becomes part of your framework of your RAG chatbot.
Got it. Okay, thanks.
Okay, awesome. No, great questions. So again, this is all part of your storage layer. When you think about building this out, think about where your index is going to be stored, where's your data going to be stored, where's your cache, if you're doing caching, where that's going to be stored. That sort of needs to be your first area. You could do something like a Frankenstein. Again, if you wanted the cheapest options, hey, if I store my vector store index using Pinecone, they're giving me a great price. Cool. I'm using MongoDB because MongoDB gives me a cheaper price on storing my data. Okay, cool. I'm going to use this to store. I'm using Azure Redis Cache because they only charge me less than 10 cents a month to do caching. Okay, cool. So then you can sort of build out and have these Mongo. It's a morning for sure. Thanks, Nagesh. To use these different areas to sort of Frankenstein these together and actually have something that's built out from different areas. And there's nothing wrong with having something like that, right? Or you can sort of have it all through one vendor and try to get a cheaper option doing this all with the one vendor side. So now that you have your vector store index and sort of we run this local, we're connecting everything together, right? But there needs to be something to communicate. There needs to be a serving layer. So what's the difference between having something like this in production versus not? When you connect, example, to a vector store index, let's go through Pinecone. Pinecone grabs your vector search index and then serves this to an API point. So it serves it to an API point, which an API point needs to be maintained and needs to be on and needs to be able to communicate back and forth, right? So when you're looking at this, it's not just, hey, I can build a vector store index. It's when you're in production, how can you optimize it, where you're pulling it from? And that's what we call the serving layer. The serving layer is what are the APIs that are connecting to the different parts in your production. So you have a vector store index, cool. You need a vector store index API point now. You have an embedding model to embed questions coming in through. If you don't have it locally, that needs to be served as well as an API point. You have an LLM, but it's not run locally. You're pulling it from Azure. Cool. That needs to be an API point that you need to pull in. So this is where we call the serving layer, in which you'll have multiple APIs that need to be served based off your documents. So your database storage, if you have it with another vendor, again, that needs to be served to an API point to be able to be saved there. And that's what we call serving layer. All these different things that have connecting into your database, connecting it through APIs is your serving layer. So either one, you either deploy your own serving layer, or you have someone else, another third-party vendor, help you serve your different areas that you have. So again, once you have and understand where all our data needs to be served and need to communicate. So again, this is where you're in your serving layer, you'll need to communicate to pull the information from your vector store index, and you need to pull it from your LLM API. And the most important part after all of this is monitoring your LLM, making sure it's okay, making sure if you're storing the inferences in your memory, in your databases, go back and check, is the model actually responding to users? Is it not responding to users? And that's the most important part. So like I said before, what are the production components? You need to store it somewhere else. So I just put Delta tables as something from Databricks, could be S3 buckets, could be Azure storage, it could be whatever cloud provider you're thinking about, where your information of your RAG needs to be chunked and stored inside those tables. Now, your index is how you're storing the embeddings of those documents in there. And this is something I talked about in GenAI 101, is talking about how each vendors that have different types of vector search indexes. Not all are the same. And there's different searches and pros and cons for each one. So example, MongoDB offers something called BM25, which is like a hybrid search of semantic and keyword search together to make you optimize your RAG. Meanwhile, something like Pinecone offers machine learning retrieval methods that does nearest neighbors proximities on your RAG search to give you better RAG. So each one will come up with different ways to say, hey, choose me as your vector stored index provider, because I can provide you different methodology to retrieve your chunks and from your areas. So when you look at building these RAGs out or something like that, look at the capabilities that each of the vector storage index has, because each one will then try to say, well, I found this result looks better, or the API is cheaper. So again, you're looking to optimize your price, but also what kind of retrieval methods it has. Yes, it looks like Oracle and other companies offers agentic AI agent, but it's recommended rather than self-built. Yes. So again, when you think about this, it's build versus buy, and again from there. But I think RAGs, you don't need to like right now, Copilot and things like that offer to do RAGs for you. But again, if you're doing something that is public facing, or you're doing something that requires more business rules than your typical Copilot has, don't trust these top vendors. These vendors will try to sell you that they can do X, Y, and Z, and then when you get to implementation, they'll say, no, this is custom work, therefore we'll charge you this custom work. Or you get to this part, like, oh, this is this. And then when you do these custom works on their systems, and because it advances so much, 3 months down the line, Q2 releases happen, and they changed exactly how that infrastructure looks like. And guess what? All that custom work needs to be then charged to you again, simply because now they updated that system to have different connectors. So that customer then needs another SOW and needs another work and needs another part that you need to upgrade and you need to change. So again, just be very careful when you think about this build versus buy, And if it's straight out of the box functionality, that's great. Like go for it. But if you need custom development and you're working with these big vendors, just note that the AI space is moving so fast that if you don't have any communications, you don't have any things staying those informations of that, then you're going to be trapped in an ongoing perpetual paying to keep your custom integration going. Yes, so there's a good question from Satya. What happens when you have information in your storage index and you need to be removed as it's stale and things going out? So this is why you would do something with this rather than fine-tuning a model. If you were to fine-tune a model on, let's say, 100 company documents, and guess what? In 3 months from now, the company says, no, those information's old. You need to do this again. Then all that cost of maybe $15,000 to fine tune a model from that GPUs, you'll have to do it again in 3 months from now, and then do it again. And guess what? Your LLM model now costs 100 grand because you kept fine tuning it every 3 months of the documents. So in order to stop and not have something like this is where RAG becomes really important because you can then give documents through this RAG to not have to fine tune it. So what happens and how can you control that the documents that are in your RAG and be used? This is really important when you think of RAGs that has the metadata filters. So you can tag when you're doing your embedding process dates, years, titles, links, departments, whatever you think of to your metadata chunks. So you can say this was made in 2025, Q3, and from this department. So when you go in and say, I need to update and remove certain information from my vector store index, you go back, okay, anything previously in 2024, I want removed because you already have that metadata filter tag on your data, and you can delete it from there using those tags, and then import the new information into your into your same vector store index. And then you can keep up refreshing and refreshing your data that way. Also, if you're having new versions coming in of documents, because you have the metadata filter of the tag of the title names, it's easy just to search for the name, swap those out, and put the new in. So that's how all that's being part of the RAG architecture. So we have a vector search index that is doing all that information. You need the endpoint. If you don't have it created, you need to develop it. And then I talked about before model serving. So where's the LLM that you're pulling in? Where's the database pulling in? Where's that architecture pulling in? All that is part of the APIs coming that's dealing with your AI architecture in production.
So for the vector search, can you go back to the previous slide, please? Yeah. So the vector search endpoint, is that not as similar to you doing a query or something like that? So is it going to be a bit more like API endpoint instead?
Yeah, so you have to have a separate API just to pull information from your vector store. So you have one API for your LLM that's going to communicate and send in the inference and send in information out. But then you need to have something that connects to your vector store and your vector store index to communicate and pull information out from that one. So that communication layer happening to pull out your vector search index is that vector search endpoint. So it's a separate endpoint, different from the LLM endpoint that needs to be up and open in order for this to work.
Okay, thanks.
So, Satya asked a good question. Delta tables are, again, Delta tables are what Databricks calls their own database tables. So, yeah, don't think about that. Again, I'm just putting these names up here because we're going to go through an example soon, so you can see part of their own Databricks architecture Delta Lake that they have. Okay, so again, for those who are just waking up in the morning and just remembering a little bit more how RAGs work, you grab your documents, you chunk them to IDs, you embed and index that document, you have it ready for query processing, and then you generate your response, right? So then make sure we're going through that same architecture and flow from there. So in order for this to happen, you need to have your documents. Your documents get then broken down into chunks, right? Then you break it two chunks, it becomes vectorized. You vectorize it through the embedding models. And then once it's in vectorized embedding models, it gets stored. So again, where your embedding model lives really depends on how you do this. This can be a local model, but if it's not local, then guess what? This embedding model also needs an endpoint. So you're not only having endpoints just for your LLM response coming back and out, you need an endpoint to have a conversation with pulling information from your vector store retrieval. And if you're embedding every single question from the user and you're embedding that response as well, that embedding model needs to be served as an endpoint as well. So when you're in production, it's not only just looking at I need to throw out the LM and need an API for that and that's it. No, there's multiple different serving endpoints you need to think about when you're doing this in production. With your vector store index, your embedding model, and your LLM model to get that response back out. So the reason why I'm talking about Databricks today is because they have a free tier. I've tried Azure's free tier and AWS free tier, and currently right now, although I say it's free, you can't really deploy on it. You get sort of a lot of restrictions, and there's not a lot of um, not a lot of information of what we can do. So Databricks just released a month ago their whole system on our free community. So this is why I gave the instructions to you guys yesterday through WhatsApp, how to sign up for a free Databricks stuff because they're now using their Mosaic AI because they want people to get familiar with their system, how it works. So I'll be using that today to walk you through how one system could use it. And again, it's very similar in other companies in AWS or Azure, but of course they have their own different names like S3 buckets versus Azure's data lakes and the data tables, but it's similar. It's similar to the same processes. So I just want to walk you through a little bit more of Databricks terminology, so where you can sort of unify yourself as we go through these demos today. Yeah. So yeah, no worries. So again, APIs is what you use to sort of communicate, and I'll walk you through the demo today. It's gonna make sense a little bit, make more sense as you see it in action. So Databricks, how they sort of look at it and approach is very holistic. They bought a company called Mosaic ML, pretty much 4 or 5 years ago, which particularly focused particularly on machine learning models, how to trace them. And what made Mosaic ML really successful was the integrated ML flow, which is a really good tracer, just like how we saw last week, how we traced models and see that with this. So Mosaic ML, you could look at machine learning models such as like regression decision trees, and whatever model you built gets saved in something called a model registry. And this model registry can show you how you built your machine learning model, and then how you were able to run evaluations from your test train set on your machine learning model to see how it works well. And it was really successful, and Databricks saw how successful that this company was and decided to purchase them. And they switched from ML, as you know, 2023, 2022 came out, they switched it to an AI system. So now instead of saving machine learning models, you can actually save now AI models to this model registry and test how that model is going. So that's how this Mosaic AI agent framework works like. It's very similar to machine learning models, but instead of us saving these machine learning models, we're now saving AI models and how they work and the evaluations. And this is something that we'll look at from there. In Databricks, they call something Unity Catalog, which is their storage and database, where they're storing information in schema, data, and tables. So again, this could be your S3 bucket in Amazon. This could be your Azure database information in there. This could be your MongoDB, sorry, MongoDB tables that you're storing in. This is where Databricks is sort of that centralized catalog comes in. They have your vector search already embedded in there, so you don't have to worry about using a third party. They do model serving themselves as well, and they stand behind it, so you don't have to worry about going something outside of it. And what's really great about this is, yes, an agent evaluation in which you don't have to go out and use Langsmith. You don't have to go out and use Phoenix AI to actually trace how to get evaluations of this, right? So all these components are integration through Unity Catalog and end-to-end governance. So what do I like? So I have my biases, and again, of what different vendors I like in terms of AI worlds. If you're building something very custom, Databricks in terms of evaluations is one of the companies that spent the most on doing evaluations um, integrated into their system. You'll see other companies that will have LLMs as judges on a very basic UI framework, very basic things. But Databricks has spent millions and millions of dollars on RAG evaluations, on LLM evaluations, which I think is really necessary for you to take this to production because you need to think about how you're going to be valuing these models. Yes, you can use third-party tools, but again, if you want to have one seamless experience, this is where Databricks does really good at. Okay, so this works a little bit different in terms of the vector search. So in Databricks, they host the index and they do the APIs itself, so you don't have to worry about going out and creating and getting it from Pinecone. They create their own, so you have everything, you have a register index inside your Unity catalog, which I'll show you, and then you just have to create an endpoint that now syncs that to an API. And we do something called Delta Sync, which is also inside their Unity catalog functionalities. So that anything there's changes, example, this going back to the question of what if you want to change data coming in, coming out, you can sort of have that done through something called Delta Sync Index, which you can actually look for information new that's coming in and sync it new to your embedding model, which is really cool in terms of having that flow of that pipeline going on. They have built-in embedding models as well already served to an endpoint, so you simply just call them, and then you just need your identification and prompts. So that's again going back to the vector search infrastructure. That's how you sort of keeping everything in. Yes, yes. So some of these providers will have some of these functionalities, some of them not. But for this purpose, in this case today, it's like this. Good question. So Smithery, Gram, and Zuplo are meant more for MCP servers, where you can serve to an endpoint and stuff like that. So they aren't Databricks isn't about serving endpoints for MCP servers, although they just released something that you can now. So they are now getting into MCP right now. But in terms of registering online for anyone, you can do it, but again, it's going to cost you money. Databricks is not a cheap product. They are very expensive in terms of storing information in. But so for now, if you want to host your MCP server somewhere else, I would definitely still stick with Zoopilogram in Smithery to do MCPs. But this is more about hosting your models and customization from that way. So yes, Satya has a good question. So yes, this is a system now that we're looking at for 101, 103, and sort of putting all of it together. And I'll walk you through that today. How can one system sort of be built already that's built for AI production work. So is it DB commit log directly used for Delta Sync to RAG and embedding models? So yeah, you can do different things. For example, if you have in your Unity catalog different data from different areas, example, the Databricks bread and butter is to pull data from any type of source and store it into their database. Like they're meant to be the top like migration centers for AWS S3 buckets, Azure, from any other data source you can think of, icebergs, even Snowflake. You can pull information from other vendors and just have it all in one area. So they're like an add-on on top of your database in which unifies different areas. So if you have stuff from Salesforce, you have information from SAP systems, you have information from, let's say, for life science Viva Vaults, all that information can be all stored in one area. So then your ML engineers, your data engineers can then start building reports, commits, and not have to pull different API reports in areas. So it's sort of just a unification. So when you're thinking about building AI models there, you would probably have to create your own section, but in that AI section, you would put in, okay, all my new rags, it's gonna be put in this folder, and which I'll show you in about 10 minutes. where you store your files, where you store your folders, and how that can sort of be pushed and synced to your embedding model. So you can have multiple databases, multiple information, Parquets, Excels, CSV stored on these areas and use that to start building a pipeline which grabs from this database, go through it, and then sync, and then it goes through the process of grabbing information, embed them, make your tags, and then sync it back to your vector store index. So there's lots of different ways of going through that. Okay, so again, basic functionality. Each chunk needs a unique ID because it's most important to keep track of your vector store index. So what is model serving? I think I talked about that a little bit before. So your model serving means a REST API. So it's an API that can communicate to different parts of your model. So the difference between this versus an MCP server is that instead of hosting an MCP server, this REST API is a communication device happening between your stored vector indexes, device starting between your embedding models and your LLM models. So all this is where you call your model serving area is being stored and saved. So again, how endpoints communicate. So when someone asks a query, it goes to your model serving endpoint to ask a question to your LLM. LLM will then look for your vector search index, will hit your vector search endpoint, retrieve that context, give it to your LLM. LLM endpoint again will then go and send that to, if you're using Azure OpenAI, your Azure OpenAI system, get the response, and then generate that response back. So you're hitting all these different endpoints in your systems in order for you to get a final answer. And the reason why you're doing this is because each of these steps are now optimized, each of these steps are now productionalized. If something were to break, you can quickly go back and see, okay, what's happening with this endpoint? Why did this endpoint not work? Or what's going on with this context? And so you're making it really a good, smooth communication process and something that's sort of productionalized in the system. So again, I said before, what's really important is your evaluations. In Databricks, there's an option to do agent evaluations, in which stakeholders can interact with the agent, with the UI, without giving neat Databricks accesses. So again, if you're to develop something quickly and prototype it, how can you give it to your stakeholders quickly? There are AI-assisted metrics. When you ask a response, it will show you, is it grounded, is it not grounded? It actually comes out with these pretty disposable things. If someone gives a thumbs up, a thumbs down to your response in the LLM models, it can then be tracked and saved inside your Databricks area. You can build evaluation data, golden data sets all inside this as well. And then production monitoring, if everything is traced, everything is being traced in MLflow. Um, and then um, and then you have delta log tables to able to go through your inputs and outputs. And all that's for being saved. So it's not only just good enough to say, hey, I have my endpoints, I have my metrics, it's done. You need to then save all that information to somewhere, right? If you're capturing all the responses, if you're capturing how well your model's doing, if you have performance metrics of saying how fast it's going, how low it's going, all that information needs to be stored somewhere, and that's called production monitoring. So again, it's not just enough to say, hey, I'm going to do an AI model, that's it. You need to say, okay, now that it's up, what now? You have to keep track of it, of the APIs that are coming up and down, keep track of all the responses coming and coming down. Is there any feedback from your AI model that's happening that you need to be able to adjust? And is it going slow? Is it fast? What is performance metrics happening through your APIs? So again, our point of this is to do a continuous improvement, identify qualities and identify any issues. So the one thing I want to note to everyone is on the bottom here is production agents require continuous evaluations and monitoring to maintain quality and trust. So just like even a RAG, anything with AI, it's easy to put something in production, but to maintain it is always a constant part. And again, for those who are product managers in this call who have that background, you know that this is something that you could see that always needs constant evolution as your user customers and your users will needs change. New technology comes out. It's constant communication, constant evolution, and working on something with AI from that part. So you can put cache also into a Delta Lake table as
Actually,
well.
I'm meant to ask that, like the Delta, if like, say, for example, this is purely the Databricks architecture or what offerings they give for each of the layers, right? What I meant to ask was, like, oh, this could be used. In the previous slides, you were talking about the caching layer, where, to reduce the cost and quicker responses, right? So Delta table could be used for that purpose as well, right?
Exactly. Exactly. You don't have to go out. Everything
Right,
you Databricks to have everything sort of built in for you.
right,
So
yeah.
you don't have to leave. You don't have to build APIs. You
Uh-huh.
don't have to choose different vendors. You sort of have everything sort of wrapped in one place.
Mhm. I
Um,
hope saying that Delta, the Databricks is the ultimate thing now.
Again, I don't want to push people to that. Like there are right now, AWS is catching up. They're doing something really cool called AWS Agentic Bedrock
Uh-huh.
Core.
Uh-huh.
AWS, Microsoft has come out with their new agentic framework as well. So again, like I said before, I could be showing you Azure today. I could be showing AWS, but
Mm-hmm.
they don't give a free tier for you to actually go and investigate and actually deploy things without running into major blocks and not getting the full area. So like I said, Databricks just came out with this new free community version where you
Mm-hmm.
actually can deploy AI systems and actually play and test it. And this is why I'm showing you guys that one because again, well, I want something that you guys can play with, understand it. So when you were to go something to like AWS or go to something Azure, you could see the difference
Mm-hmm.
of how things work.
So sorry, Luis, for another question. So based on your, you are exposed to quite a bit of these varied platform or vendors, right? Like Azure or AWS or Databricks or any of those things, right? Which one do you see is more matured, at least to a point where you don't need to, like mix and match, like, oh, I'm in AWS because I'm vendor logged in for whatever the reason, but I need to do a mix and match with few other custom built things, whereas Databricks or some other vendor now gives a complete matured offering. You name a thing, I have it available. Which one is?
Yeah, so that's a very good question. And again, I don't want to be very biased in my opinions,
No, no,
but
based on your usage, right? Based on
yeah.
your exposure and usage.
So to me, how I evaluate how well vendors are looking into something that's very mature is I look at evaluations
Uh-huh.
and it's easy to say you could build a RAG on my system. It's easy to say I can build an AI agent on my system. It's easy to say that, and it's easy to build. But how you actually evaluate responses and actually go into look at it shows me the maturity level of, hey, let's just get people on our AI agent platform. How can we get them set up and going? Like, yes, that's important, and you can get that going in. But to me, when I look at a stacks and I look at the maturity level, how is the evaluation stack? Because that means someone's actually sat down, thought about the product, and is mature enough to understand, hey, it's not good enough just to put something in production. You need real monitoring statistics.
Mm,
So if I look at something that says, hey, if, if this actually is the latest and greatest in analyzing how an AI agent is supposed to do, because if you're giving three tools to an AI agent, and you wanted to decide, I wanted to use a SQL, I wanted to use the line graph, I want to use this, what evaluations are you going to be able to give to your agent evals to say, did it choose the right tool when I asked this question? Like you need to like now it's about analyzing the flow rather than just answering a basic golden answer pair. You need to analyze, are these flows right? Are these flows wrong? And you need someone who's but mature enough in that system base to be able to build that. So again, in terms of maturity level, there's very few vendors that I've seen that are deeper into that space. And this is where I sort of put my bias towards Databricks because they have spent millions and millions of dollars inside their evaluations to make sure it's all seamless. And we'll be going through some of that today. But in terms of evaluation capabilities, I found that Databricks is one of the top ones for evals. For scalability, Azure has been really pushing, and they just had a week on Microsoft following up on different ways how to keep expanding the agentic space. And they've come out with a really great framework. And then AWS, I think, comes in right now for me as third in terms of the AI maturity space as it goes on. So That's my list. Don't take that as a Bible. That's me just practicing and me working and viewing these different capabilities. But again, one thing I want you to note that Databricks is not cheap. They're one of the most expensive vendors, I would definitely say. So again, you're paying for convenience, you're paying for these things. But again, if you have your vendor locked in to AWS or Azure, there are workarounds. But if you ever jump on an AI project, please focus on that. Please focus on the evals. All right, I'm going to finish this slide, and then we're going to take a 5-minute break, and then we're going to go to the demo that we have. So again, conclusion, our production AI agents require a complete infrastructure. Example, storing, indexing, serving, and model layers that all work together. The model endpoint must communicate seamlessly with the vector search endpoints that you have, your LLM points, and if you have any external data sources, you need to have that great serving layer happenings. And you need continuous evaluations and feedback loops, which are essential for maintaining quality and improving the agent's performance over time. So again, building a model is just the beginning. Production deployment is where the real work happens, and this is where you need to actually build a committee afterwards to then do this. So last thing I would say is it's easy to say, okay, we're building this out and we're going to get that there, and you can have a good group from it. But then you need a committee afterwards to say, how are we doing in terms of evaluation? Is there if it's customer facing, is our customer metrics going up or going down based off this information? What data needs to go into our data to our AI agent or to our RAG base, right? And that's a constant communication. Now that's going to constant upkeep. You need IT and people who are maintaining this. You need AI developers who are on top of this. And it's a constant work after production release. So again, for those who are new to how these production releases, there is a lot of work that really happens from there. That's a good question, Satya. So, okay, awesome. So I'm going to take a 5-minute break from here, and I'll meet you at 9:10. It should be good. So if you have a question, I can answer it quickly during this break time. But
Yeah, you said model endpoint, right? Like it got me confused that LLM is a model itself, but this model endpoint is essentially the agent endpoint, which encompasses everything that you talk to, right? Which is RAGs, vector, I mean, essentially the vectors and LLMs and like any other things, right?
yeah, so just remember, like I said before, like when you think of Databricks, it's not just having AI agents. It could be machine learning models.
Sure. Makes sense. Right.
So they just name the word just model because it could be different types of models that you have. So that's why they communicate that way.
Right. The words are so overloaded everywhere, right?
Yes.
Model, LLM, come on, they're different from different context actually.
Yes. So
Or broader, right?
yes, for sure. Okay, awesome. All right, take your 5-minute break, take some water, and we'll start working the demo after this. All right, I think we're back from the hour now. I'll start sharing my screen. Okay, so yesterday Manal shared a link with everyone in the WhatsApp, so you should be able to have this link as well. This is where we're going to be going to today, Learn Free Edition, where it says Learn Professionals Data and AI Tools for Free. So this to me was really impressive. They came out with this just about a month ago, where you can now be able to actually use Databricks without paying for a fee or paying to do certain things. They actually do free training as well. So if you go on this page, you can click free training and actually walks you through how to deploy things, how to walk through these areas as well. If any questions, there's a community for those who are trying free as well. There's a lot of tutorials. Shows you actually how you can build AI agents inside these free editions, visualize trends. You can talk to you how to use Python Notebook, data engineering, different parts of things. So there's a lot of cool things happening with this free edition. And all you have to do is click sign up. So everything is based on the cloud, so you're not using any GPUs yourself, right? So the difference between doing something like this and something local is because you're paying, you're having something on a GPU, you're having someone else run it. So of course, anytime you run a task, anytime you run like that, there is a cost. But because we're using the free edition, we're not going to incur any costs. Everything is free. Databricks eats the cost eat the cost for this because they want you to get familiar with the tools to see if you like it and going from there. So I'll go ahead and you just sign up for free edition. I'll ask you to put your email in, you just sign up, and it brings you to the main page. So this is how the main page looks like. Example, you can see that you whatever email that you sort of signed in at the top here will have your top, you have your email, have your workspace. When you click on workspace, your home, you probably won't see these folders in here. This folder I gave to everyone. So if you'll check something called DBC, so in the WhatsApp group, there is a file in here that's called DBC. All you do is click import, import that file, and you choose that file that we gave you through WhatsApp, and you just click import. Simple as that. Then you'll be able to have this book called GenAI Cookbook, and which will have different items for you to review and to look through. So this is how the Databricks platform looks. It's really simple. They try to make it very minimalistic. You have your workspace catalog on the left side to show you where the different database systems that you have. Again, if you're using, again, this is all stuff that's made up, right? Because then you're using the free system. So they want you to show you how you can store functions, how you can store models, which LLM models you're able to use in your system, how billing is used, prices, usage, of course. This is all like dummy data, right? You can click through and go from there. But yep, everything is stored in here. And this is what you call the data catalog, where you can create, you can add data. So you can create a catalog, which is your main source of folder. And inside your catalog, when you create it, you can have different databases inside. So example, this one could be strictly all about Salesforce catalog. Next catalog could be strictly about AWS S3 buckets. And you can have one named after each area, or you can have each name after line of business, and you can have different databases under each one. Of course, each one can be restricted based off role-based permissions, and only certain people can have access and see certain access to certain information from here. Jobs and pipelines is what you can do to run things that can be sent as jobs. So example, we talked about before, how about you can have new data pulled into your vector store database. You can set up a pipeline here that pulls information from a certain database, checks if it's not in your vector store index, and then embeds it and runs. So again, this is a simple of a job that's constantly being run as a job logger, where you're pretty much tracing how that metrics and logs look like every time, and you can see how it succeeded or not. Again, you're very in control of how everything is run. So again, just like Amazon, AWS is run on a lot of things are run serverless. You can also do serverless compute here as well. And for those who are getting new in technology, what is this name of serverless SQL warehouses and everything like that? Is that in order for you to run anything, Python notebooks, anything in terms of running even a simple SQL query, all this requires a SQL warehouse. So example, you can't create a SQL warehouse here because it's because you're in a free version. You don't know how to do one, but they give you the serverless one. And this serverless one, you can switch into where you want it to be coming from. But this is how your model runs on. So if you're running big information, you have to create a large serverless warehouse. If you're having thousands and millions of data running through your system, you need a large. If you're having medium-sized information, medium. If you're running very small information, small. And of course, each one obviously contains a cost. The smallest one is the smallest cost you can have. Medium, obviously large, depending on the cost. So they did something called serverless because what happens is when you create these warehouses, there's a cost to have it turned on. So a serverless warehouse is one that you don't own. Databricks owns this warehouse, again, this SQL, this that warehouse that you have, and is able to then to say, we don't have to shut down ours, but if you need information, you only have to pay when you use it. So again, the point of having a serverless warehouse is for you to save cost and make it speed because they can say, okay, you can have, we'll be running a large warehouse on our side, and we'll use that to feed many clients as they come in through different requests. So that way you don't have to shut down. You can only use what you need, and we'll provide you the best experience that way. So that's what a serverless warehouse means, that you're using Databricks' warehouses that's meant for many different users. But again, you get speed and you don't have to worry about setting things up and getting things from there. I won't touch data engineering because it's out of scope, but really interested in here is the AI and ML playground. Just like Amazon Bedrock, where you can play with different LLM models. In the free version, there are different models here that they give you free to play with. So example, I can talk to the GPT OS. This is ChatGPT's open source models they give you for free. Llama 4 Maverick, Meta's free open source model. Gemma 3 12B, which is Meta's free open source model as well, and all these other ones from Meta from here. So that's Google's Gemma 3 12.B, and then the Meta ones are from Facebook. And you can see here that you can see something called use endpoint, right? So the models aren't built locally in the system. These models are being served to the users through an endpoint, which we'll look at last. So if I want to use this, I simply just click use endpoint, and then I can say hello and actually talk with these open source models without paying extra money. So again, we're on the Databricks Free Community Center. And we're not paying to communicate and interact with these models to see how well they're doing. And remember we talked about how there's different evaluations. In here, we have a built-in evaluation of AI judges. So it checks if texts are safe or if texts are relevant to the user responses. They even suggest other responses that you can give out as well. And all of this is all built out the box. You don't have to about setting things up. You can always test these models using these type of formats in different ways. You can add tools. So this is where you would add an MCP server if you wanted to. If you want to add a vector search index, that we'll talk about here. So example, this is our one that I created, and I say what documents do I have access to? Okay, so again, the free version, I guess it doesn't let you go down that deep. But in typical areas, you should be able to connect your tools to your vector search index and then respond from there. So that's how fast and easy it is to play with these playgrounds and get in there. Next is the experiments. We'll talk about this more as we get down and working on our own webpage. But here's is actually where you can actually train a model and fine-tune a model. I think is it here? Let's make sure it's in the right place. Yeah. So it's on experiments. You can create a custom model for AI agents and fine-tuning a model in your experiments. So it's simply just clicking on fine-tuning a model under Gen AI apps and AI agents, fine-tune a model. You choose the model you want to fine-tune. You upload the data set you want to click on, and you click start. And that's how simple it is. And you start your model from there, and you fine tune a model. Your model then gets saved on Databricks, and you can use that for your testing. Just one thing to watch out for, though. Remember, fine tuning is costly, and you're using their servers, so be very wary of and do your due diligence before you fine tune a model on Databricks and how much data it is and how big the model is. All that will depend on cost. But again, this is the free version, so feel free to look around and play with things so you can get yourself familiar with how different things look like. They have customs of building your own machine learning models. You can either do it walk you through step by step, or you can build an AI app, which you can say test AI agents. You can create artifacts. You can develop locally. They tell you actually how to generate the keys, how to create the codes. And you simply just copy this to one of your notebooks. And you can either do it in Python or through TypeScript. And you can get that information going on right away. So we'll talk a little bit more about how this sort of works, but how quickly and it shows you how quickly and fast you can start developing locally, and start building your own AI agents within seconds. Models is where I told you I've talked about how your model is being served. So, example, going back to the GPT-5 OS, GPT-OS open source model. This is a model made from OpenAI. This has to be served to a point, which we'll talk about here. So, the models is where you create your model card. So remember, I talked about before, if you were building machine learning models, they would go in here. If you were building AI models, your agent work, they would go here. If you're getting information from another model, like OpenAI, from AWS, and you want to import them in here, this is where they would go. So you can see here, there's a bunch of models being saved that are being done. And it's simply as going to, okay, this is a model, we saved it, it looks good to go. We simply just serve the model. And when you click serve, this deploys it to endpoints. This is where your endpoints will go in your serving model. So here, you have to have your embedding model in here, and you need to have your AI agent model in here. So you'll see here there's lots of different models you can pull in to serve that you can communicate with. So example, there is, like I said before, GPT-OS 20B. When you click on it, obviously they're not going to show you where the endpoint is, but you can see it's up and ready, it's running. You can edit the gateway to add AI guardrails. You can create input guardrails, safety, PI detection. You can block behavior, you can mask behavior. All these things strictly out of the box coming out of these AI gateways. So your model doesn't have to think about, I want to block it. These gateways block the response before even going to your flow. So that's the difference between having good guardrails in place. It's not just about having guardrails in your production pipeline. You can even put it on your API serving that before it even touches your pipeline, it gets blocked right away. So the reason why you want to do this, because sometimes there's prompt injections, hallucinations. You don't want it to poison whatever data set you have. You can build these AI guardrails right away and have them block the system. So that's pretty much just a quick overview before we get into it. Yes, so budgeting for Databricks is very challenging. You need to, if you were building this on enterprise, again, you can negotiate just like any other vendor for pricing. So how Databricks works on is something called DBUs, which is the Databricks price per unit. And running something will cost 0.5 DBUs or 0.25 or 1 or 2, 3, 4, and 5. And depends on how you negotiate the cost of each DBU, really can really calm down your prices or make them really high. So you can make each DBU like 0.0035 cents or something like that. And then when you run it, see how well you're doing. It's like, no, this doesn't make sense to me. I want to stop. So they'll come and negotiate with you afterwards. But again, there's really good Databricks calculators online to be able to use. And then when you see the calculator, you're able to see, okay, if I have this, how much would it cost? So I think I could pull that up quickly. I think it's called Databricks Generative Calculator. Yeah, Generative AI Pricing Calculator. So just like Amazon, Azure, it really depends on what the cloud system it's being hosted on. So if it's AWS, Azure, Google Cloud, you can host different things from Databricks on the cloud provider. So I'll just click AWS for now. Depends on your region. So I'll leave it US East. It's typically the #1 server you would have. And you can choose which model you want to see the costing of. So again, it depends on the model. Again, I showed you before that it costs higher to use some models versus not. So I'll do Llama 3.158B, which is a very small model. And it's going to ask you, how much queries do you think you're going to have per minute? So this is like an average token. So again, you can leave it there. So let's say two people, let's say one person per minute. How much would that cost? So then it gives you that calculation here of it's going to cost you to run this monthly $30. And again, this is assuming that someone's going to hit your chatbot every single minute to ask you a question, right? But let's say you have 50 people, you're extremely popular and your chatbot's going through the roof. 50 people asking for a minute, how much would this cost? As you can see, 1,425, the jump increases. So what if I want to use a smarter model? We know that for Opus is really smart and I get 50 queries per question. What's the cost jump? You can see how quickly an open source model, Llama 3.18b, that was only 1,000 something for about 50 queries a minute, jumps to $135,000. So because Claude charges a lot of money for their Opus model. It's one of their highest thinking models that they have. Versus if you're using an open source model like another from Cloud from Google, the price is only 1,458 per month. And using something open source from OpenAI, 723, you can see you can drop these things very much, really depending on how well the model performs, versus choosing the latest and greatest. As you can see here, even choosing the second tier model from Claude is going to cost you $27,000. So do you really need that Claude power? Is Claude going to give you that big step? This is where, again, use this pricing calculator, go through it and sort of see what you think is really best for you. Okay, so in the workspace, before we jump in, when you upload the document, there will be something called GenAI Cookbook. And we'll just click quick start demo. And this is called Mosaic AI Agents 10-minute demo that we'll be working on today. So when you click on that, it should bring you to this page of how the demo looks like and go from there. So unfortunately, because this is the free version, I had to edit this to be usable because there's a lot of restrictions in terms of not being able to read, not able to write. So if you use the version I gave you through WhatsApp, you will be able to run this without any issues. So it's going to talk to you about, it's in the WhatsApp group, Nagish. If I put it there, it's called a .dbc file. Yeah, so Swami, how Databricks works is it's not its own cloud platform. So Databricks is not AWS, it's not Google Cloud, it's not Azure. It's an add-on that works as a top layer on top of it. So if your main provider is AWS, you can use Databricks on top of it. to then pull everything from your S3 buckets into Databricks as your main hosting file and pull any other company data you have into Databricks so it's all into one unified area. So that's why you see AWS, Azure, Google Cloud, because they integrate with them to sort of work together as an add-on rather than replacing your current infrastructure. Okay, so this one talks about hosting an app review. We won't have time for that today, but it just shows you quickly how you can ask questions, you can make responses, and then you can save them and look and get feedback sort of being saved. We'll go through today how you can build agent evaluations inside it as well. And this is sort of outdated now because the cookbooks aren't there, but how it works. So in order for you to run anything on Databricks, you need to connect to a database to run to like a GPU or warehouse. So this is what I said before. Serverless is sort of defined for us inside this because it's the cheapest version that they have for the people in free. So you simply just click serverless and wait for that to connect. So again, you guys are not paying for this at all. Again, if you were to run this on your enterprise data, this would definitely cost money, but they want you to try to get familiar with their system, so they're willing to bite the cost for these things. So first we're going to install a couple of packages for this to work. So we're going to install Databricks agents because we're going to be using their agentic framework. We're using MLflow for evaluations because MLflow and Databricks work really, really well together. These are different versions of MLflow of analyzing it. We need to install our Databricks vector search package to ensure that we can enable a vector search for our information. Our Databricks SDK to enable to communicate with an LLM. And we're going to be using LangChain as our main Python function core to sort of wrap everything together. So as much as Databricks doesn't have a Databricks framework, doesn't have anything like that. What Databricks is trying to do is saying, hey, you bring any custom AI agent framework you want, we'll just help you host it and work from there. So again, you don't have to use this LangChain. You can use LangGraph. You can use any other framework you could think of that's open sourced can be used in here as well.
I'm sorry, when you're going to import it, are you going to say new and then do the import, the
All you have to do,
import of the data? Yeah.
yeah. So sorry, which part of it?
I'm referring to getting the cookbook.
If you get the cookbook, all you have to do, I said before, when we missed it, was then when you go into your home and you're in this section, all you have to do is then click import from these top three buttons and you upload the .dbc file in here.
Okay, cool, thank you. Sorry.
And then once you close it, you should be able to see a folder called GenAI Cookbook. And inside that folder, you should see something called Quick Start Demo and 10-minute demo. I know some of you might want to follow along, but unfortunately, Databricks is very slow when you deploy endpoints. Sometimes it takes 20 minutes, sometimes it takes an hour to deploy certain endpoints, even in enterprise areas. So again, this one I'll walk you guys through it. I ran through yesterday, so we don't have to go in and deploy your own areas, but I can show you how all this works. So we're able to run our first file. We're installing our packages. Again, it's going to hit the serverless function just like how we do on Google Colab. So you can see this is very familiar to a Google Colab type of feel, where you have your Python notebooks and you're simply running things, running your installation packages that you need again, and boom, it's installed that we have. So this function does install it. This function here just says, okay, now that we installed it, let's restart the page because we have our packages downloaded. So it's telling you here, hey, if we need to install the more cookbooks information, so let's install it. You simply just click run. So what it'll do on your warehouse is that when you go back and look at your warehouse functions, because you already have a GenAI cookbook in here, it created another one, and another one it shows you it pulled out all this information in here. So you can have more ways of doing different types of demos. So we're doing 10-minute demos, but there is Mosaic AI agent demo, bring your own data, and there's a 60-minute RAG demo too as well, where you can walk through and do the steps as well. So we're installing that, and we're going to pull all this from this GitHub and store this on our Databricks warehouse story. So because I already got this, it says already exists, and we're going to stop the creation. So just in case we don't get an error, we're good to go. So in order for us to get started and for us to work, we have to decide where the information is being stored and what information are we having. So we need to create a warehouse, a catalog in our systems in order for this to happen. So when I ran this on the free version, what happens was this code doesn't create anything. Right here, we're just simply saying, these are the names we want to be created in our workspace. So that's fine. But we need to then create this ourselves. So you might before I ran this into an error, simply because right now the free version doesn't allow you to do automatic creations. So what you have to do in order to get this running is, let's go back to our second page, go to catalog. You're going to do something called create a catalog. We're going to call this rag underscore m1 release. And you just click create. And that will then, when you click create, will then create this catalog that you see here, rag underscore m1 release. And it will show nothing, simply because we haven't developed anything yet. But somehow in the free version, because there's so many restrictions, it doesn't allow you to create a rag catalog automatically. We'll just do it manually. That's fine. But that's the first step for this to be successful in this project. You have to do rag underscore m1 release. We'll come back and we'll run this. Now that we have this there, it will create subfolders in our area. So we'll create this database called 10 minutes, our default information schema. So these will be blank as well, but as long as we have now our framework, we should be good to go to do what's next.
Actually, Luis, I could not find the place where you are looking at the 10-minute thing. I had to do search to find it, and also that run is failing, saying that I cannot find something there.
Which one are you able to find the notebook? Were you able to import the?
Yeah, I'm able to find the notebook, this 10-minute one, but so third step, that the util step is check if the UC catalog and vector search point exists. That step is failing actually.
This one here?
Let me tell you.
This one, sorry, which one, or this one?
Vector search endpoint exists. There's a title called the below one, actually. Yeah.
Yeah, so you need to, this was I was saying before, you need to create this catalog.
I see. And I created just now. Let me go to the, so after creating, I need to run the previous step again, maybe.
You can run the previous step before.
Okay, got it. Okay.
Yep.
So it needs to have a specific name for the catalog, the same one which you mentioned, or I would think so, right? Rag ML release. Okay, all right.
So when you run this, you should check, and if you don't get any errors, that means we'll see if we have it here. So this just calls in making sure we have all the endpoints and make sure if our catalog and schema exist. If not, it will create it. So we ran it and saying, hey, actually you have one, your catalog exists, so it's good. And your schema, we have created that for you, exists now, so it's good. So it should show you that you'll be able to you have now created a catalog and a schema in your Unity catalog.
Do you need to configure it, because there is like a step for configuring as well, right?
No, just you can leave that be for now.
Okay.
Luis, in which folder it is? I saw I imported your DBC and I see it in the.
So do you see the generic cookbook
Yeah, and then I cookbook under a 10-minute demo folder is there. Yeah.
So quick start demo, and there should be Mosaic AI agent 10-minute demo.
Quick start demo.
Actually, yeah, our folder structure is a bit different, Luis.
I think we are not seeing this one.
Same, yeah.
Do you see this one? It should show the same thing.
Oh. See, what we have is under GenAI cookbook, we have
10-minute
10-minute demo. Yeah, there is a folder
folder
called
is
10
there.
minute.
In
Yeah.
that folder, there is a Mozilla AI Me Agents 10-minute demo. That one is there.
Under
Okay.
GenAI cookbook only, we have, yeah. Then there is a folder called 10-minute demo.
So what I'll do is I'll download this as a Python file. I'll put this into the Zoom just to make sure that everyone is under the same things, just because I downloaded everything as a zip file, which is really strange. I sure everything should be in there. So let me just put this in the chat for you guys to have.
So do you want us to re-upload or something, or what is?
Yeah, so I'll give you this Python notebook. It's really weird. It should be in there, but you need to put it exactly where it shows here, GenAI Cookbook, and then the Mosaic AI 10-minute demo should be there.
So we keep the existing one and import this one as well.
Yes, just in case, because a lot of people say they can't find it. Just import this one if you can't find it.
Yeah, that was in a different folder. Yeah. Okay, let's import again.
If you're able to find this, these are the most important ones that you need to look for. All right, so once you created your catalog, and you should have M1 release, M10 release exist, it should show that it exists. Now, this is where I think you'll be able to follow along from this point from here, because we're going to create a vector search index. So in order for this to actually have a vector store up and running, you need to create one. And it's going to create one in our schema. So you need to run this one to create a vector search endpoint. When I ran this one, says this can take up to 20 minutes, up to half hour to run. So when I ran this below, to create a vector search index for us to start using and pointing our information to, you need to develop for it first. So I'm creating this when I click run. It's going to create it. Well, of course, it's already created from yesterday. So it's saying it already exists, so I don't need to create it. But when you get to this point, this is where I was saying it's going to be a little harder for you to join, simply because, again, this will take up to 20 minutes for you to load. And this eventually, this is what happens in production as well. When you create these endpoints, you need to create these things on, doesn't matter for enterprise, they still take 20 minutes to load and to develop an endpoint, because it goes through all the Databricks engineering, it goes through its safety, and it gets registered into it, and then all these different build endpoints that need to be happening as well. So once we have our schema and we're able to develop a vector search endpoint, and you can verify that it exists, then we're good to go to start working on how to deploy something onto this. So typically what you would do is you would have a clean data set, we chunk it, and then we give it to our area, right? So in order to save time on this demo, you should find something called Parquet in this. So let me just double check if it's in here. It should be this Parquet file. So I'm going to tell you if I can download this one. I'll put this into the chat as well, just in case you can't find it. So what this Parquet is, it's already a document that's already been grabbed, it's been chunked and split for you, so you don't have to worry about the chunk and splitting. If you want to do chunk and splitting and you want to learn how to do that, there is another cookbook in here that helps you to do that on their GenAI cookbook. Sorry. It's called the RAG app simple code. and it walks you through how to create an evaluation, how to get the pipeline, how to review it, how to extract it that way. But due to time, and I want to focus on what are the main agent evaluations. So what we're going to do now is that now that we have the Parquet that I sent you on the Zoom, we go back to our catalog, and because we can't upload it, we have to do this manually as well. So again, I think on our 10-minute schema we have here. Let me just make sure. Yeah, we have something called volumes. And all you have to do is click on this, and then you just click on where is this? Upload data. So where you're going to upload it really shows you from here. So we're going to upload the documents to our M1 release catalog, to that schema we created above called 10 minutes, and we'll upload our demo volume. So that means we got to go to our M1 release, our 10 minutes database, and our volume. Here's where we're adding in that Parquet file. So you're gonna have something called demo volume. You click upload to this volume, and that Parquet file that I showed you and I put in the chat, you simply click upload. So this file, you click open, sent, and you click upload, and that's all we have to do. And if you upload it properly, you'll see the Parquet file name here that you uploaded successfully, that Parquet file. So for those who don't know what Parquet means, it's like a zip file for text. So we're just uploading a zip file of text that's already been chunked. So we don't have to go through and show you the processing of grabbing a document, chunking it, and getting that the whole process to be saved. So we're just uploading that to show you that, hey, there's something we already have that's in there. So to make sure that you properly imported it properly, please run this line. And if you upload it to the right path and volume, you'll see a check mark, and you'll see that it's able to read successfully your Parquet file, the string, the chunk ID, and the URL. So you should be good to go from there. If you're having issues, it's like, oh, it's not reading it, remember, double check where you're storing it. It should be following this exact same pathway of where the Parquet file is. So now that we have a vector store index endpoint already up to be used, now we have our data. The next step of building a RAG is to put it into a vector store index and serve that to our model. So this one below will take 1 hour to run. And what we're doing here is grabbing the data. We're making a chunk table called chunks chunk. I can't speak right now. Chunked docs delta. Let's say that 3 times fast. Chunked docs delta to store where our delta index is being stored in, where our chunks index are going to be looked at, and where our vector search endpoint needs to be done. So this must already exist. So I'm saying we create this vector search endpoint above. So whatever name you have, maybe it's under your name, not under my name. You need to change that to whatever vector search endpoint name you created up here. So right now, because it's under my name, under my files, I was going to say Tikas Luis 1, but if you have under your name, could be Nagish vector search index, right? Could be under your name. So when you go to this part, make sure that the vector search index name that you change it to becomes changed here. So this one already exists, and where the Parquet path of where our information is, and what we're using to embed it. So we're going to be use Databricks embedding model that they have because it's free, it's in here, and we don't have to mess around. So these are configurations that we control. So we're showing where exactly our schema is, what kind of tables we want to create, where our volume is, and our embedding path. So we're going to tell it step by step what we wanted to do. So one, read that chunks from the Parquet. Once you have read that documents, we need to obviously extract that information out. So extract the information out to something called chunks delta table. Now we just want to capture it, so make sure we're doing okay. So change data feed so vector can sync and track updates. We're just making sure we can track what's happening. And then once it's already in that table, we sync our vector store index to our chunks delta table. So now that's already created, we're going to go tell our vector store index, hey, guess what? We have our area for you to work on. So here's our chunks, embed it, and store it there. So then this model is going to go in there, look at the Parquet file, extract information out, put it to a table, and then start putting the embeddings on top of it as a new row. So when you run this, we have about 8,000 files, 8,000 rows of data in our file. So it's going to take over, I think it will take over an hour for it to finish in terms of doing all the 8,000 in this area. So for the demo, what I showed before was I was able to run this, and it shows you, we can quickly go through it. So how does that look like? So it's saying, hey, it's already created. So we're going to skip creations. So when we go to our vector store data table, we should see two tables that we were able to successfully pull out from our Parquet. So remember before we said, hey, pull out a delta table of all the information that we have that was inside the Parquet. So I can't click on it because I don't have a cluster to view it. Let me see if it lets me choose a wireless. Let me see if it lets me. Okay, let me come back out. Okay, cool. Let's see if it lets me view it. Okay. So from the Parquet file, it unzipped. Remember, so think of Delta as an unzipping of the Parquet file. It shows what's already in here, right? It shows that these are chunks from Databricks documentations. So grab the documentation, split them into chunks. We have a chunk ID of what that chunk number is, and we have the URL of where it pulled it from. But is that enough to create a vector store? No, right? We need to have this embedded. So that's what this job does. We create that first part to extract it from the Delta table. The next stop is to then embed that process. And we told it to create a new table to embed it called chunks docs index. So this is going to be our vector store index table. So it created this. And as you can see here, that the format of what table it is changes. So because this is a vector search index table versus a normal Databricks table, just note that there is a cost difference of hosting a vector search index table and endpoint versus hosting a normal data table. So that's something, again, you'd be very wary of. Production, a lot of people they are not for free. But when you're looking at this in terms of your own areas, but again, this is where you're able to go in and view what's happening. So let's see if it did it properly. We told it to embed it. So we see a new line compared to our Delta table, right? We see this DB chunk text vector float items. Okay, so then we go to our sample data and let's see how that looks like. So we still have the same chunk text that we saw extracted from Parquet. We still have our chunk ID. We still have our URL. And boom, now we have our embedding vector store. So this is what our RAG sees. So remember going back to Genai 101, your embedding model is what converts normal text into your vector tokens that you can see here on this right side. So an LLM doesn't see what is the latest and greatest in shoes. It sees this text vector response coming in. So how does this work? Because this is now numerical and vectorized and numbered, when someone asks a question, you can do the same thing and convert that question to a vector as well. And then you compare how close is that vector to this vector. Because now we're comparing numbers to numbers, right? We're comparing how those two numbers can be very similar to each other. Now we're not comparing words to words because that's really complicated. what we're doing is comparing that vector store to that vector store. So when you're doing a RAG and you're pulling up the top chunks that are most familiar to what the user's question, you're pulling it based off these numbers that are very most similar to what the question's being asked. Yes, so when you do that similarity search, going back to Swift's question, it will look at this column first and calculate a score and say, these are the top 5 chunks that have the highest score to that user's question as similarity search. So then these 5 chunks get sent to the LLM along with the user's question. So then the LLM looks at these chunks, looks at the user's question, and say, oh, okay, now I can formulate a response. And then uses this information and answers it out. And the reason why we do this is because LLM cannot do more than its context window. And you remember, it can only read so much information at a time. So as much as we want to give it the whole PDF documents of all this information, it will get stuck. You'll be costing a lot of money to yourself because it's now reading a bunch of input documents that are very costly. And you're filling it with a bunch of information that may not be relevant. So this is why you do RAG. You're only feeding it the most relevant information it needs in order to answer the question. That's why RAGs are hit and miss, because if you don't set up your RAG properly and you don't send the right chunks to your LLM, it won't get you the best response. There is a cool feature that before we even start creating anything, before we start even developing it, simply because we have an embedding document, you simply just click try in Playground. And I think this is where you go in before, and you could say, what is Databricks documentation? I don't know if it's going to work because, again, this is our preview site. And let's see if it works or not. So our vector search index is what's responsible for identifying which matching rows and responses are sent to the LLM. So remember what I was saying before, how different LLMs have each LLM has different pros and cons. So, example, the vector search index in Databricks has hybrid search, has semantic similarities. There's different ways you can set up and configure to retrieve the information from your vector search index. I think it's going to take a long time because I think I chose the 120B. So, okay. So actually, okay, great. So we actually built an LLM model without even going through the extra steps right away. You can see, is our model able to respond to things right away? And because I simply just creating the embedding model, try and Playground, within 2 seconds, we're able to choose whatever LLM now we want. What documentations do you have access to? It's going to our vector store index and able to pull out the responses and develop a RAG within an hour, right after you create your vector store index, and you don't have to do anything else. And guess what? You can simply just click Get Code, create Agent Notebook, and you have your notebook of how to create an agent already set to go, and you register and deploy it. And that's how simple and easy it is on Databricks. Sorry, this is new. This is too new to me, but I know all the functionality, so that's awesome. So that's one shortcut way of doing something really fast on Databricks, where you can tell it to choose which model you want, run it, click run, and then boom, you can register a model and see how that goes. So I want to see how this goes myself. So I'm going to click run and run all. I'm going to run everything, run all. While this is running, we can continue with our own notebooks ourselves. So now that we have our vector store index, we go back to our code and continue. So how this is going to work is we need to make a configuration chain. So what's really important is we're going to say the model we want to use, the vector search endpoint, where the vector search index is, and what is the context we want to give to our LLM to how to answer, right? So again, your prompt engineering. So you're an assistant that answers questions. Use the following pieces of retrieved information to answer the questions. Some pieces of context may be irrelevant, in which case you should use them to form the answer. So we define our chain here. And we're using MLflow to sort of view that trace. So let's double check that everything is already. We have our endpoints already in here. Don't worry about this one. This one just simply just checking what kind of resources we have. I was just doing that as a double check to ensure that we have the right resources. So you need something called sample ragchain.py in order for this to run. So again, it's in there again, but just in case you do not have this file, which to be seems really weird that some of it is missing, I'm gonna put this in the chat as well again, and you put it exactly where the other parts is. So quick start demo, sample ragchain.py, exactly where your 10-minute demo is. I'm gonna put this in here into your files. Because this is how your chain is gonna work. When I click that file, it's gonna show you how it's gonna run, how the configuration is running, so you don't have to worry about setting anything up. And now that we have this, we're gonna tell it to call it to run this same file. And when we run this chain file that up from below, we're asking a question to this model here. We're going to say, hi, hello, and how do I use Databricks vector search? So if we did our job properly and we're able to create the right documentation, just like we saw in the other place, we should be able to see an MLflow logging of that question and response. And just like how we saw in last week's lesson, we should see a trace of what's happening, of what's going on. So we don't have to go to Langsmith. We didn't have to go to Phoenix. Databricks builds in these evaluations already, so you can see step by step what's happening. So you can see that it ran this section first, extract the user questions, format the chat for history, extract chat history if there was, and then pull the information from our vector store. As you can see here, it pulled 5 documents that are mostly related to our response, formats the context to see what's in there, brings it back to our LLM, and then it gives it to our chat Databricks to then give a response. And then boom, we see our response from our user here. So this is why to do something like this is very useful, very training, because what if it pulled the wrong context? It's not answering the right questions. You can go here and view which responses, which chunks it pulled, why it pulled those chunks, and then you're saying, oh, actually, I should have put better metadata on this, or I should have done this better. And you can add assessments to say, hey, I actually want to give a feedback to this and then create this, right? So there's many tools you can add on to get better evaluations of this. Just due to time, I'm just going to run down to the most important parts. Is next you want to deploy the application. So how do you deploy it? So we built our app. We have it going. I won't be able to run this time because it's already created, but you click run. And when you click run, it creates something in our model feature. So going here on our models, it will create Wasteticus Agent 1. So it's showing us that in version 1 that we sort of created, it created this model of our documents and have all the artifacts, everything that we've created is now wrapped up into a nice little package. And that's what creating a model does. Creating a model card saves the model that you created, all the code that you created with it, and how to serve it. So when you have your model and you're like, okay, I want to now serve this to an endpoint, Databricks makes it super easy. All you have to do is when you have this model card already up, you click on serve this model. When you click serve model, it's going to tell you, okay, what name do you want to give it? New endpoint. You need to point it to the quick start model that we just did. We're on version 2, because I'm on version 1. We're using CPU. and we want it to be the smallest one. In order for you to deploy it, you must scale to 0. That means when you're not using it, it goes to 0, or else you won't be able to deploy. And how easy it is, you simply just click create. And that's it. We developed our model, we put the embeddings, we chose which model in our prompt template and which model we're having, and we click serve. So this one takes about ½ hour to serve your models each time. But when it's done, you should see your model set up here, now under serving. And if something goes wrong, you'll see failed. But because I made everything sort of perfect, you shouldn't have any issues. So when you click on this, on your serving model, you should see that it's on an endpoint. Just like our MCP server was and how it was /MCP, this one's called invocations. And this is how you serve a model to a front-end endpoint. So how does this look like? When you click use, you can see on the left now, it's like a API request. And when you click on how do I use Databricks Vector Search Index, and I send a request to our model, it's going to send this out just like how on a chatbot on the front end, you're sending a communication between your model and the backend model, and you're having that conversation happening. And that works through your model serving endpoint. So when you send something from your front end that you developed, maybe it's a custom UI, maybe it's a Gradio, maybe it's a Flask app, whatever app you're using, you put this as the communication where it's going to pull information out and respond. So if someone were to write, how do I use Databricks Vector Search Index? Your endpoint's going to come and return this response to your front end. So then your front end all has to do is extract where your content is and display that as a response. And that's it. So you simply created an endpoint that now connects to your vector search endpoints. You have an endpoint that you can connect to any front end on any system simply just by using a URL. So when you connect to your front end, you're connecting it using a URL and not the actual model itself. And this is why the serving endpoints are really important, because you go to production, this is the one that you said before, you can put guardrails on, you can force things on, you can make sure it's safe and ensure that what's happening. And again, you have metrics already, how latency of it, how many requests are coming in, how many errors, what's the CPU usage, etc., etc. I'm seeing how well it's working that way as well. So with an endpoint, you're keeping track of what's happening and what's going on. The last 2 minutes I want to talk about is the evaluations on this. So how do you evaluate something like that? So again, you need a golden data set. So here I put a response, like it should be expected response, and the content it should be pulling in, and then the expected response from the model. So this is the response the model gave and the expected response. So again, I'm doing something just to be really quickly. And we create a sample evaluation set that we have our data, our expected response. Again, this is curated manually. So you can see a delta table of your request ID. Here's a request. Here's a response. And here's the expected retrieval context and expected response. So we're going to judge how well the responses does against the expected response. So to do this, we simply just make sure we point our model to it. And we run literally 4 lines from MLflow, which is called evaluate our model based off that data set. So when we run this, it's going to start evaluating and creating an MLflow run showing our evaluations. It shouldn't take too long, so because we only have 4 questions, it should only take 7 seconds. So when it's done, we have MLflow showing us, hey, the exact same response. How did it answer every single question? And we see LM judges on the right side to say if it's actually right or wrong. So to get deeper into the ML judges, you can click View Evaluation Results. And then we can go to our traces. And we can see here the question we did, the response. And on the right side, was it correct or was it not correct? And why was it failing if it was not correct or not, right? So again, it's failing. Why did it fail? So our product question is REST API. So it tells you why it fails. as well. So this is where you go deeper down into your evaluations and drill down to each questions to find out, hey, why is my chatbot not able to answer certain type of responses? But are we done here? No. Let's go back and see what the latest and greatest in Mosaic AI evaluations are. So to see what the latest and greatest, I put this extra code here at the bottom to see the new evaluation prediction features that it has. And it has pretty much a brand new scene. And I'll click on that. And with that, we'll be able to end today. That is so much information, guys. This is why I put these into different sections, but we'll get deeper into them as we go to 104 as well. But if you click view evaluation results on these newer type of evaluations, we can see here our evals are 4 questions. And this time we have more metrics. We can have correctness, relevance, retrieval, and safety. And you can sort of define your own LLM judges as well. You don't have to stick to these LLM judges as sort of your end all. You can create an LLM judge based off the context of your company and have it evaluate that on those type of responses as well. But the point of this is saying you can see the user's input. What's the output? Was it correct? Yes or no? Did it pass? Was it sufficient? Was it safe? And then you click add new assessment. I want it to be a feedback. I wanted to make a new assessment called checking does Databricks approve? Like Databricks approval. And I could say, would Databricks approve of this statement? So something very custom. And see if it's true or not. So you can create your own rationale. You can add in your own LLM judges and see how it responds to this as well. So again, this is all using LLM as a judge to evaluate your responses as well. So again, in one system, you have one system that takes your chunks, embeds them, puts them to your vector store index, serves your vector store index endpoints, has and hosts your LLMs, interacts with your LLMs, and then not only does it do that, it also evaluates and helps you drill down to that responses. And if you think, wow, okay, that does everything, there's still more. If you go to compute and you click on apps, you can create an app now from your Gradio, Flask, Shiny, Streamlit, Node.js, and connect the app that we just did. We said we want to create a chatbot. Choose it to the endpoint we just created, because remember now, it's only pulling from the API. It's going to use this API endpoint to communicate. We choose the next model we're having, next, and then we can put our description and then click install. And boom, we have now an internal chatbot that we created that's built on an app that can now be shared internally with how many users we want, and externally if we how many users we want as well. So this is really cool. This is really important. And I know there's a lot of questions around the technical aspects around the API, but just due to time right now, guys, I just want to show you, not to get deep into the weeds, but how quickly something can be integrated. Please note that all this documentation is online. And I really hope you share the same excitement as me, in the sense that there are really ways to really build AI fast, easy, and safe. And that's the most important part when you're developing these areas, especially if it's going to be customer-facing chatbots from that end. So again, I guess when I thank you everyone for being with me the last 6 months, like 6 weeks as well. Some of you have been here with me over 6 months as well, but hope you really understood that this is more of an intermediate course. You really felt that there's a step above than basic definitions, getting deeper into actually productionizing the systems, learning more about MCPs, fine-tuning the different types of technical aspects, and really felt this. I hope you really felt that this course was really that next step level. So again, thank you so much for joining me.
Thank you so much, Louis. That was great.
Awesome.
Thank you.
Okay, great. I'll
Thank
stay
you,
back.
Louis. I think unless we learn, we don't know that we don't know.
Yes, for sure.
No, thank you for your time, and then they're very deep insight. Looking forward for 104, and then maybe practical steps. Yeah.
Awesome.
Thank you, Louis.
104 is going to be very hands-on, no slides. It's going to be strictly coding. So for sure.
Thank you.
And then there are no office hours next week, right? Or-
Yes, that's it. Yeah, we finished from here. All right, thank you so much, everyone. Thank you. Hope you enjoyed it.
Yep.
Thank you, everyone. Yeah. Have a good weekend. Yeah.
Close.
Have a good weekend. Bye.
Bye for now.